Welcome back to my tiny series about the fundamentals of Python. If you haven't seen part 1 of the series yet, please jump over and watch that one first. If you have, however, I hope you played around with the concepts we went over so far, and have a basic understanding of variables and data types in Python. In this episode, we'll go over functions, classes, iterations, and selections, and we'll program our first 3 minigames. So, let's jump right in. Let's start with selection statements, also known as branching statements or decision-making statements. We can use them to select which part of the program should be executed based on a condition. In Python, you can do this using either if structures or match cases. If structures look something like this. If condition A is met, perform code block A. Otherwise, check whether condition B is met. And if condition B is met, perform code block B. Otherwise, if none of those conditions are met, perform code block C. So that's the basic structure of an if statement. If you want to use an if statement, you will always start with an if, followed by a condition and a colon. Then you go to the next line, use an indentation, and tell the program what is supposed to happen if the condition is met. You can either use this condition on its own, so that nothing happens if it's not met, or you can chain conditions together by using elif for the next statement, and or the else statement to have something happen if none of the conditions are met. You can also use as many elifs as you want, chaining as many conditions together as you see fit. Let's look at an example. Okay, in this small program, we declare that x equals 3, and then we use our if statements to see how big x is. So if x is greater than 5, the program will print out x is greater than 5. Since x is 3, and therefore smaller than 5, that statement will be completely ignored because it's not met. So we'll go over to the next line. The next condition is checking whether x is smaller than 2. And if x would be smaller than 2, it would print out x is lesser than 2. This statement will also be ignored since it's not met. So we'll go over to the next line, which says else. And this line will be carried out if none of the conditions above is met. Since x is not bigger than 5 and is not smaller than 2, none of the conditions are met, and therefore the else statement is met. And the program should theoretically print out x is neither greater than 5 nor lesser than 2. Let's see what happens. And there you have it. The program is printing out x is neither greater than 5 nor lesser than 2. If we would change x now to be equal to 6, for example, like this, and run the program again, the result would be that the first condition is met, and therefore it completely ignores what comes after the first condition, and just does what the first condition is telling it to do. In this case, print the sentence x is greater than 5. So far, so simple. But you can also chain conditions together. Okay, in this program we chain conditions together, telling the program that in the first step it should check whether x is greater than 2 and smaller than 5. This will only be met and the code will only be carried out if both conditions are met. In the next step, we checked whether x is equal to 3 or whether x is equal to 10. This code will be carried out if one of both conditions are met. So it will print out x is equal to 3 or to 10 if x is 3, but also if x is 10. We'll see that in a second. And then again, we also use the else statement to print out something if none of the conditions above are met. So let's see what happens if we say x is 6 and run the program. As you can see, neither condition A nor condition B are met, and therefore we're using the else statement. So what happens if we say x is 4? In this case, condition A is met, for it's bigger than 2 and lesser than 5. But what would happen now if we would say x is 3? Since that would meet condition A and condition B. So would it print out both? Or which one would it choose? Let's see. And as you can see here, condition A is met and therefore condition A is carried out. Python will ignore everything that happens after one condition is met. So since condition A is already met, Python will ignore that condition B also would be met. Instead, it carries out whatever is said in condition A and ignores everything that comes after it. On the other hand, if you would say x equals 10, it would carry out the code in condition B. For condition A is not met, it goes over to step 2 to condition B, and condition B is met, so it carries out what is defined under condition B. So the most important thing to note if you work with if statements is that if one condition is met, Python will not check whether the other conditions are met too. If you want Python to check more than one condition, you have to chain them together in the same line, with an AND or an OR statement. But you can also check for a true or false statement, doing this. In this if statement, using the word not, Python would not check whether x is greater or lesser than something, or whether x equals to something. Python would check whether x equals false. And that's basically all you need to know for now. With this structure, you can have certain parts of code being carried out if certain conditions are met. For example, you could use this to track what happens if a character's health points fall to 0, or what happens if a user makes a certain input. We will see this kind of structure a lot while making our games, so please make sure you understand what's going on there. Another selection structure we can use is the match case structure, which looks something like this. Match a certain variable and check whether the variable is 1 or 2 or something else. It's basically like a game of memory. Check the variable and match it with its counterpart. This kind of works similar to the if structures, but scans for specific cases. So let's see it in action. So in this code, we created a variable pet and gave it the string cat. And then we used the match case structure to match the variable pet to a string. So if the string saved in pet would be dog, Python would print out you're a dog person. If it equals cat, Python would print out you're a cat person. And if none of those conditions are met, Python would print out time to get a dog or cat. So as you can see, the match case structure is pretty simple, but not as mighty as the if structure. Let's see what we've learned so far. I'm going to write a few lines of code, and I want you to stop the video for a moment and think about it. What would the code print out? Ready? Perfect. Let's run the program. And as you can see, the correct answer was the question, was it too easy? Which I hope you can answer with yes. These statements might still seem a bit confusing or abstract at this point. But with a little bit of time and training, this will become the easiest thing in the world for you. For now, congratulations! You've achieved a basic understanding of selection statements and earned a new achievement. Another programming structure that will come in handy in a lot of situations are the iterations, the while and for loops. The while loop looks something like this. While condition is met, carry out this code. In practice, that will look something like this. So in this code, we've defined two variables. We've defined x as being equal to 10 and y as being equal to 1. And then we'll set the while loop and say that while y is less than x, it will print out the variable y and then increase y by 1. So we could also write it like y equals to y plus 1. But the easier way to write this is like y plus equals 1, which basically tells Python set y to y plus 1. So in this case, y will become greater until it's no longer less than x. The moment the condition isn't met anymore, the while loop will stop. So let's run this program. And as you can see, the numbers from 1 to 9 are being printed out. That is because we start the while loop with x being greater than y, and then Python prints out the value of y and increases y by 1. And then the loop starts over and over and over again until the condition is no longer met. Which is also why you only see the numbers printed out from 1 to 9, but not for 10, even though at the end of the program y equals 10. For the moment y becomes 10, the loop is no longer being carried out, as the condition is no longer met, since y is no longer smaller than x but equal to x. So the moment y is 10, we don't carry out the print function and the y plus equals 1 anymore, and therefore 10 is never being printed out. This whole concept could come in handy in situations where, for example, a character is moving into a trap. In that case, you could use the while function to say, as long as the character remains in the trap, take 2 points damage every second. Which would also mean that the moment the character doesn't touch the trap anymore, he would stop losing health, as the condition is no longer met. On the other hand, we have for loops. For loops are iterating over a sequence, like this. For each element in this list, print out element. In this case, you would tell Python to go through the list and print each item of the list. Let's see a specific example. So in this example, we created a list with the elements stage 1, stage 2, and stage 3. And we are now using the for loop to loop through this list and to print for each element in this list, you've completed this list element. Which, as you can see when we run the program, gives us you've completed stage 1, stage 2, and stage 3. This could come in handy if you need to iterate through a whole list to compare it with something. Or, for example, if you program something like a Pokemon game, you could store the Pokemon you have with you in the list, and then iterate through the list to distribute experience points after a fight. Okay, time for another quiz. Let's see what you've learned so far. And let's combine both loops. Let's use a while loop and a for loop together to level up Pokemon and print out what the combined level is in the end. What do you think which value would be printed out for x here in the end? This is probably going to be a bit harder, so pause the video again, think about it, and then unpause it. See you in a second. Done that? Perfect. Let's run the code. And as you can see, the result is 30. Why is that? Because the while loop was activated 10 times. Each time adding +1 to z, until z was also 11, and then the condition was no longer met. While going through the while loop 10 times and activating the for loop each time. Going through the list of the mons, adding 1x for each mon in the list. So each iteration of the while loop added 3 times 1 to x within the for loop. And since we went through it 10 times, 10 times 3 is 30. Got that so far? If not, please watch the section one more time and try to understand what we did here. If you got this, however, congratulations! You've mastered iterations and earned another achievement. As you might have realized by now, code can get a little bit complex. And even though you might know exactly what you're doing right now, a year later or even just a day later, you might already have forgotten what certain parts of your code are doing. That is why it's best practice to have a good documentation style. And the best way to document what you're doing and why, or to what end, is to use comments. Comments are bits of codes that are more or less hidden from Python. So if you write something with a hashtag in front of it, Python will ignore everything that comes after the hashtag until you get to a new line, looking something like this. This line of code starts with a hashtag. So it's appearing this gray because, for what Python cares, this is a comment. And everything I write after will be handled as a comment, and Python will not handle it as a piece of code. Let me make that a little bit clearer. Let's write a new line and write a print statement in it and then run the code. And as you can see, if we run the code now, nothing is being printed out. Because even though that is correct code and we use the print function there, since we wrote a hashtag in front of it, Python is handling this as a comment and not as a piece of code. So if you want to keep track of what you're doing in your code, you can always write a hashtag behind the line of code and then write a comment behind of it. The next line will be handled as a piece of code again. But you can also write multiple line comments. For that, you would use 3 quotation marks, like this. And as you can see, if we run the code now, it still wouldn't print out anything and wouldn't give us any error messages. For all of those are valid comments. But to make a little bit clearer of where the comments start and stop, let me write some more lines of code. As you can see in this code, I've used a few print statements. One print statement after a hashtag, which should be handled as a comment. One print line in the next line after this comment to see whether this is going to be printed out. One print statement in the line after we used 3 quotes. And one print statement after we used 3 quotes again. So let's run the program and see which ones are going to be printed out. And as you can see, the print statement after the hashtag is not being printed out, since this is a valid comment. But the print statement in the next line is, for the hashtags are only meant for one-line comments. The print statement within the multi-line comment is also not being printed out, as this is also handled as a comment. But the print statement after the multi-line comment is being printed out. So this should give you a visual idea of how comments work. Hashtags are for single-line comments and 3 quotes are for multi-line comments, which are handled as comments until you use 3 quotes again. So Going forward, please don't hesitate to use comments within your code to make notes for yourself what the code is doing and how and why you did something like this and maybe not the other way around, so that if you come back to it after a longer pause, you can still see what which part of each code did. Next, I want to talk about functions with you. Functions are basically mini programs within our program, like shortcuts. We define them once and can then use them as often as we want throughout the program. We've even used a function before, the print function. The print function is predefined by Python, and we are calling it whenever we need it. But we might need other functions throughout our program, so let's start creating our own functions. Functions always consist out of a name and a pair of parentheses, like we saw in the print function. To define it, we would use def, like this. So to create a function, we would use the signal word def for define, then give the function a name and use a pair of parentheses. Afterwards, like always, use a colon, and then in the next line, with an indentation, tell Python what the function is supposed to do. In this case, with the signal word pass, I basically told Python that this function is empty. You can't have a completely empty function, so if you want to have a function without anything happening in it, you will always need to use the word pass. But we could also use this function to print something, for example, like this. So now, if we would call this function, it should print I am a function. To call this function after we defined it, we would basically do the same as we usually do with a print function. So, within our code, we would call the function by writing its name and a pair of parentheses, like this. And only now the function would be carried out when we run the code, like this. So as you can see, we define the function and then we call the function. And by calling the function, we tell Python to carry this function out. In this case, to print I am a function. But why do we have the parentheses? Why don't we write anything in it? Well, the parentheses, as used in the print function, are usually used to give the function parameters. For example, like this. Now we've changed our code a little bit. So we still define the function myFirstFunction, but we put name in the parentheses. This is called a parameter. Since that is now in the parentheses, every time we will call on the function now, we will have to give it a name, or at least we will need to give it a value for the variable name. And then we changed our program a little bit so that the function now prints out I am a function giving out the name, and then basically giving out whatever we give it. So if I would run the program like this now, without giving it a name, this would happen. We would get an error message, basically telling us that Python is currently expecting an argument for the variable name, but we haven't given it one. So if we instead now give it a variable, like this, and run the program again, the error message would disappear, for we've given the function now an argument for each variable set. In this case, we basically called the function and gave it the string myName for the variable name. And so the function is being carried out and prints out I am a function giving out the name, and then basically the string we just gave it, my name. If we would put a name in that instead, it would give out the name. And if we instead of a name just give it an integer, for example, it would print out the integer, for we basically never told Python what kind of data type we expect for name. But in the print function, we told Python that whatever it is, it should try to convert it into a string. So in this little project, we defined a function giving it the name myFirstFunction, told it that it has to expect a parameter, the variable name, and told it that if this function is called, it's supposed to print out something. And then later we called the function and gave it an argument for the parameter. and it printed out what it was supposed to print out using the argument we gave it. And that's basically what a function is. You define a function, you tell the function what it's supposed to do once it's called, and then you can call it like a shortcut to not have to write each line of code every time again and again, but basically just say, yeah, what I'm trying to write is already within this function, so call this function and carry it out. One more thing you need to know about functions. Within functions, we might use more variables than the parameters we just saw, basically, to get the results we want to get. We would define these variables like we did before, but this time within the function, like this. So this variable is a little bit gray right now because we never called it, we never used it, we just declared it. But this variable will only be able to be used within this function, for this is a local variable. So any variable defined within a function is a local variable, while any variable defined outside a function is called a global variable. You can work with global variables, so with variables defined outside of a function, within a function. But you cannot work with variables defined in a function outside of a function. Basically, local variables, the variables within a function, only exist while a function is being carried out. To make that a little bit more clear, let's try to print out this variable outside of this function. And as you can see, we would get an error message. For Python currently doesn't really know which variable we're hinting at. For the variable currently doesn't really exist. It only existed for the moment the function was carried out. And now that the function isn't currently being carried out, the variable basically doesn't exist, and we never defined a variable outside of the function. So in short, please note, if you use variables within a function, or better, if you declare a variable within a function, you will only be able to use this variable within this function. To work with variables outside of functions, you have to declare the variable outside of the function. Let's have some fun with functions. One predefined function in Python is the input function, looking like this. So let's use this function and let's create our first minigame. Let's create a game of Mad Libs. To create a game of Mad Libs, we will need user inputs, and then we'll need to work with these user inputs to print something. So let's first define our function. Okay, so far we've defined our function MadLibsGame and told it that we want to have a parameter, username, just for training purposes. Then we'll take this parameter and print out hi username exclamation mark. And in the next line we basically welcome our player and ask him to enter something. Now we need to use the input function to get an input of the user and save it in a variable to work with it later. This would look something like this. X equals input, please input X. If we would run this now, the input function would ask the user to input something and hit enter to save it. He would see please input X as a text, after which he can input something. And once he hits enter, his input is going to be saved in X. And with that, we would be able to work with it later. So let's get some real inputs. So I've now prepared a few real inputs. So we've declared a few new variables, like word 1, movie, adjective 1, and so on. And for each of these variables, we will get an input of the user. And every time he hits enter, he will see the next input he can do. And his inputs will be saved in the variables. And then the last input function basically only tells the player to hit enter to start the game. So, and now that we have all the player inputs, we need to do something with them. So now we would use the print function to print our Mad Libs text and use the variables within them, like this. So this would be our first print statement. The print function we just wrote will now print, did I tell you that I went to the cinema the other day? I watched the sequel to, and then we'll use the variable movie. And for the variable movie, the user has input a movie name earlier, here. So now we're using the text with our first variable. The only thing we need to do now is writing more print statements for all of the other variables. I've already prepared this, so let's do this. Okay, so I wrote a few more print statements now, using all the inputs of the user, so all the variables where the inputs of the user were saved in. So the only thing we need to do now with our function is to call it, like this. We've defined our function, giving it a name and giving it a parameter. Then we use the parameter to say hi username. And then we use another print method to welcome the player to the game. And once that was done, we used the input method a few times to get the player inputs and save them into variables. And once we had all the inputs, we used the variables the inputs were saved in to write text with the player inputs, using print statements. So the function will do that now every time it's called. So the last thing we needed to do was to call the function and to give it a value for the parameter needed. In this case, Mad Libs game random name. If we now run the program, it should carry the function out, greeting us with random name, welcoming us to the game, asking us for a few inputs, and then giving us a text with the inputs we did. So let's try this. And as you can see, it welcomes us with hi random name. Welcome to a game of Mad Libs. Please enter the following to play. And then it asks us for our first input, a verb ending in ing. So we can click into this line now and give our first input. Once we've entered something, we need to hit enter. And then it will ask us for the next input, and so on and so on. Let me quickly put something in for each of the inputs required. Okay, now we've entered something for every input line we needed to input. After we hit enter, the console will show us our print statements with the inputs we used. So in this case, the text is saying, did I tell you that I went to the cinema the other day? I was watching the sequel to Avatar. It was tiny. The people behind me were drinking all the time. It was really loud. I couldn't stop walking. At least the movie was okay. The main character was weird, but for some reason they kept repeating "Long live the king," which was kind of odd. Well, I think it will be a while until I watch the movie again. Maybe in 5 years again. And that's it. That's our game of Mad Libs. Not all the inputs really make sense, but that's kind of the point of the game. So that's it. You've successfully created and used your own function, set a parameter, and used the input and print function to make a functioning game of Mad Libs. Congratulations for creating your first minigame. Okay, now we know about variables, lists, iterations, selections, functions, but we're still missing one important part of object-oriented coding: classes. So let's take a look at them. Classes are basically blueprints for creating objects like a button, a player character, or an enemy. They are an essential part of programming in Python, and look something like this. They are declared by using the trigger word class, giving the class a name, and using a colon. Afterwards, you can give the class as many functions and variables as you want. The x we've declared here would be a so-called class variable. We talked about global and local variables earlier. The third kind of variable is a class variable. This is a variable declared within a class, but outside of any function or method. While we would globally access a variable x by just calling x, we would access the class variable globally by first calling the class, using a period, and then calling the variable, like this. So inside of the class, we can work with the variable as normal. So inside of the class, we would just say x. But outside of the class, we would first need to call on the class and then use the variable of the class. So in this case, class name dot x. Let's look a little bit deeper into this concept. Let's create a class named PowerUps, like this. We've now created the class PowerUps and given it an init method. The init method is more or less predefined. You will always write it as underscore underscore init underscore underscore and in parentheses at least self. Written like this, the init method is something that is automatically being carried out upon instantiation, or in other words, as soon as an object is being created from this class. So if we now want to create an object from this class, it would look like this. An object is always created like this. You give the object a name and equal it to a class and give it all the parameters necessary. In this case, we are telling Python that heart is an object of the class PowerUps. Since the init method is asking us for parameters, self and name, we have to declare the object using these parameters. The parameter self just points to the object itself and does not require any more action. But the parameter name, on the other hand, needs to be defined upon creating this object. So in this case, we gave the object heart the name heart. So upon creation of this object heart will inherit all the functions and all the variables given in the class PowerUps. In this case, also the init method. And therefore, upon creation, everything in the init method of this class will be carried out. In this case, the init method will print PowerUp plus the parameter we gave to the object plus created. So as you can see, if we run the program now, it will say PowerUp heart created. Once more in short, an object created from a class will always inherit all variables and all methods of the class itself, and will carry out the init method of the class upon creation. If the class has other methods, on the other hand, you would need to call them manually. But why do I keep saying method? The init method looks like a function, doesn't it? Well, yeah, methods and functions look exactly the same, but the difference is that methods are basically functions declared within a class. I've got to admit that I tend to say functions instead of methods sometimes, but as a general rule of thumb, functions exist outside of classes, while methods exist within a class. The exact difference is the following. So, objects inherit the variables and methods from classes. But not only objects can inherit from classes. You could also create a new class that inherits from another class. Let's say we want to create a class potions, and we want to have different kind of potions that all should have the same attributes only potions have. But at the same time, they should also be power-ups, and inherit all the variables and methods of power-ups. In that case, we would create a potions class like this. We've now created the class Potions, and as you can see, in opposition to the class Power-Ups, this class is using parentheses. That is because the parentheses are telling the class Potions which other class it inherits from, so which other class is its mother class. In this case, Power-Ups. So in this simple step, we already told class Potions that it's a child class of the class Power-Ups. Then, in the next step, we gave the class Potions a variable type and gave it the string Potion. This variable is unique to the class Potions. So the object Heart we created from Power-Ups will not have this variable, for it isn't an object of the class Potions, but of the class Power-Ups. And Power-Ups does not inherit from Potions. It's the other way around. Potions inherits from Power-Ups. So this new object Healing Potion would now have all the methods and all the variables of the mother class Power-Ups, and additionally would have all the methods and all the variables of the child class Potions. In this case, the object Healing Potion would have the variable type Potion, and upon creation, it would carry out the Potions method in it. In this case, we told the class Potions that in the init method, it should also ask for a variable name and then should inherit from the mother class method init. We told Python that by using super. Super is always pointing to the mother class. So within the init method, we told Python, take the init method from the mother class, and then additionally, print the sentence, I am a potion. So if we run this code now, we would create the object Heart, which inherits from Power-Ups, and would carry out the method init from the Power-Ups class upon creation, and then we would create the object Healing Potion, which would carry out the init method of the Potions class upon creation. But the init method of the Potions class also says to carry out the init method of the mother class Power-Ups and do something additionally. So if we run this now, it looks like this. The object Heart says Power-Up Heart created, while the object Healing Potion says Power-Up Healing Potion created, I am a potion. To make that a little bit more visible, let's define a new function in the mother class, like this. Okay, now we give the mother class a new function, the function description. So, since it's not in the init method, it will not be carried out upon creation of the object. Instead, we would manually need to call it. For that, we would also first need to define an object, and then use that object plus the function to call the function. So to carry out the function, we need to call on the object, put a period there, and then call the function. And if we run the code now, we create the object carrying out the init method of the Potions class, and then call on the function description to carry out the function. And in this example, since this worked, and the description function printed out I am a Power-Up with the name Healing Potion, you can see that even though Healing Potion is an object of the class Potions, and the method description only exists within the mother class Power-Ups, all of the functions of the mother class are inherited by the child class Potions, and therefore every object made out of the child class Potions will inherit all of the variables and methods from the child class, as well as all of the variables and methods of the mother class. As mentioned before, you would use this concept, so classes, to create, for example, enemies. You would define once what an enemy is and what it's supposed to have as attributes and what it's supposed to be able to do, so what functions or method it needs. And then you would just create objects out of this class, without needing to create the same lines of code over and over again for each instance of an enemy. That would also make it easier in the future to change something about the objects. So, for example, if you created a class enemies and gave it a variable color and the value green, and then you've created a lot of objects out of that class, so basically every enemy object is green, but you say that, well, that was the wrong color, I want them all to be red. You would just need to go into the class and change the variable from green to red, instead of having to change every instance of the enemy. So this concept can save you a lot of time. And with that, you've basically learned all the basics you need to program in Python. Let's put our knowledge to the test and create 2 more minigames. First, let's create a number guessing game. For that, we will need to use the input function to get player inputs, and then if statements to compare whether the player input was correct, or if not, to tell the player whether he guessed too high or too low. And to make it more interesting, we'll let Python create a random number between 1 and 100. So let's go. First, let's create a random number using Python's inbuilt range function. So in this line, we basically declared the variable x and gave it a random number between 1 and 100. Before we do so, however, we will need to import the module that inhabits the import function, like this. So the first line of this code tells Python to import the module random. This is a module that comes with Python. We can also make our own modules, but that's a topic for a different video. So in this case, we tell Python to import the module random, so we can use anything that's defined in random. And then we told Python to declare variable x and give x the value of a random method to create an integer between 1 and 100. And to prove that it works, let's use the print function and see what happens. So, as you can see, if I run the program now, it prints out the value 87. If you did the same, you probably got a different number. So let's see what happens if I run the program again. 96, 74, 38. So as you can see, now Python is giving us a random number between 1 and 100. So we have something our player can guess. Let's take away the print function. Okay, fantastic. Now let's define a while loop. While the player input does not equal our x, let him guess again. And we'll do this like that. So, with this simple while loop, we would now basically say, as long as the player input, so the variable player, is not equal to x, the variable player will always be redefined by the input of the player. So in this case, every time the player input does not equal x, the player will see guess the number between 1 and 100, and then we'll be able to make a new input. Let's run the program and try it out. Whatever number was generated for x is not 22, it's not 33, it's not 44, it's not 23. I could guess and guess and guess again now. But let's make it a little bit easier for the player. Let's give him a hint whether his input is too high or too low. And how do we do that? We're doing that by using if statements. we now used some if statements to check whether the player input equals x, whether it's lower than x, or whether it's higher than x. So in the first step, we check if the player input equals x. If it does, then the program prints out, that's correct. Congratulations, the correct number was, and then it prints out x. If the player input does not equal x, it will go to the next step and check whether the player input is smaller than x. And if the player input is smaller than x, the program will print out, not quite, guess higher. If the player input is not smaller than x and not equal to x, it will go to the next step. We could have written elif in player greater x, but since that's basically the only option left, we can simply write else. So in that case, if the player input is not equal to x, and if the player input is not lower than x, it basically has to be higher than x. So the program will print out, not quite, guess lower. So let's try it out. And as you can see, the random number generated in this run was 42. We've guessed a few times until we got to 42. And in between, we got hints whether we have to guess lower or higher. And that's basically all. With these few lines, we've created our first guessing game. Congratulations to the creation of your second minigame. In the same manner, you could let the player guess like colors or objects or whatever you want. In that case, you would tell the while loop to loop until the player input, and in that case a string and not an integer, equals the string you're giving it. And that's all. That's how you make a guessing game in Python. Let's use our if statements a bit more, and let's create a quiz for the player. This time we'll create a variable to keep track of our player's points, like this. Then we'll welcome a player to the game using the print method. And then, for each question, we will use print to print the question and input and the variable to store our player's input. Once that is done, we'll compare the player input with the correct answer. If it's correct, we'll add a point. If not, we'll hop to the next question. So this is the first question. We print the question itself, like question 1, which country has a unicorn as its national animal? Then we'll grab the player input in the variable player input. And once we have the player input, we compare whether the player input equals the answer, in this case Scotland. If it does, the player gets a point by increasing the point variable by 1. And we also print out correct. If it doesn't, we'll print out, no, that's incorrect, the answer we're looking for was Scotland. And in the same manner, we'll create a few more questions. We basically copy-paste this part and just change our questions and answers. Okay, I've created now 5 questions in total. Once we ask all our questions, we will want to let our player know that the game is over, like this. And furthermore, we may also want to let our player know how he did, so how he scored. So let's print out his full score. So with the last print statement, we basically tell our player how many of 5 questions he got right. But what we can also do is basically tell him a little bit more. For example, if he got everything right, we may want to tell him, well done. While if you get everything wrong, we may want to tell him that he has to do better next time. We can do that by using the match case selection statements, like this. With these simple match case statements, we basically tell Python that if the player has 5 out of 5 questions correct, let's tell him everything's correct, you're a rock star. While depending on how many he actually get right, he might get a different message. Like, that was good, a good start but you can do better. Well, I think you should brush up on your geography, you still have a lot to learn, or oops, try to do better next time if he doesn't get anything right. So let's see how it looks like if we run the program now. Okay, so if we run the program now, we are welcome to the quiz, and then we are given the first question. Which country has a unicorn as its national animal? Well, the answer, as we saw before, is Scotland. And if I enter this, the program is telling me correct, as Scotland is the right answer. Question 2. Which country has a white flag with a red dot in the middle? The answer, Japan. Question 3. Which country is famous for its pyramids and pharaohs? Let's get one wrong on purpose here. So, let's say instead of Egypt, let's say, I don't know, France. And as you can see, as France is obviously not the right answer, our program will tell us, no, that's incorrect. The answer we were looking for was Egypt. So let's go over to question number 4. Which country is called the same as a continent? And the answer? Australia. And the last question. Which country is called like something you can find on a Thanksgiving table? The answer we're searching for is actually Turkey, but let's say Hungary. And the program will tell us again, no, that's incorrect. The answer we were looking for was Turkey. And since it was the last question now, we will now see, that's it. Thanks for playing. You got 3 out of 5 questions right. A good start, but you could do better. And that's it. That's all we need to have a player play a quiz in the console. Congratulations! You've successfully created 3 minigames in Python now. Mad Libs, number guessing, and a quiz. You've truly earned this achievement. You're nearly ready to embark your journey to create real games in Python. But before we end this episode, let's have a look at how we can create a screen in Python, so that we can create our next games, our next tutorials, on an actual screen. To do that, we'll need Pygame. So let's install Pygame first. First, go to your console. In this console, type pip install Pygame and hit enter. Once you've done that, you should see a few more lines, which basically confirm that you just installed Pygame. To see whether you really installed Pygame, you would need this command, pip show Pygame. If you enter this command, it should give you a few lines, and if it does this, it should confirm that you have Pygame installed. So this should now confirm to you that you have Pygame installed. This will be important for our next tutorials, so before you go to any other tutorial, please make sure that you have Pygame installed. With that out of the way, back to PyCharm, and let's create our screen, like this. These 2 lines are telling Python to import the module Pygame, and then to initialize Pygame, so that it's up and running when we work with it. Next, we want to create the screen itself. So that is how we create the window. We first set a variable screen width and screen height and give it values to represent the screen width and screen height in pixels. Then we create an object screen and equal it to pygame.display.setMode, which is already predefined in Pygame. And that we give the variables we just defined. We can also just put the values in here directly, but sometimes you need to work with screen width and screen height, so it's better to set those as separate variables. That would actually already be enough to create the screen. The next line, pygame.display.setCaption, is just there to set a caption for the window that is going to appear. You will see where it is in a second. But before we run our code now, let's first create the game loop. This bit of code is basically telling Pygame, as long as the variable run is true, check for any event, check for any user input, check for anything that's happening. And as soon as that event is quit, meaning as soon as the player is hitting the X button in the window, close the window and stop the program. So if we run our program now, this happens. And there is our window. It's 800 pixels high and 800 pixels wide. And as you can see, the caption we set in the code, my window, is appearing in the upper left corner. And the last bit of code we just coded is basically saying, as soon as we hit the X button, quit the program and close the window. And there you have it. As soon as you click X, the program stops and the window closes. And that's everything we need to create a window. So please pause this video, copy this code, and save it somewhere. Because from now on, for every tutorial, for every game we make, we will need this as a basis. We will always start with this. Maybe with a different screen width and screen height, and maybe with a different caption. But this will always be the basis on which we base our games. Once more, congratulations. You now know the basics of programming in Python. You're able to create minigames in the console, and you know how to create a screen in Pygame. You've truly earned this achievement. In the next video, we're going to program our first real basic game. And then we'll expand from there. Until then, please play around with everything you just learned to get a better feeling of everything. I'm really looking forward to get into game programming with you next time. So, see you next time. Bye!